All right, it's 1 o'clock. Let's start with this first coffee lecture of our new series about ChemDraw, and I will be showing you some new functionality that might be useful for your research workflow. First of all, at ETH Zurich, we have a site subscription for ChemDraw. That means you can access this via the following URL, or and then you have to search for ETH, or you can use this short link here to more quickly access it. And then what is important, you have to use your top level email address, otherwise there might be trouble. So your username at ethz.ch. And if you're at another university that also has a site subscription, you should also be able to find your university there. So what do I want to talk about today? About 5 different topics that I will shortly present you some example. The first is Helm and FASTA for proteins and DNA and other biosequences. Then how you can import a CIF file, so crystallographic data, and what you could do with that potentially. I will show you 2 new shortcuts and remind you where you can look up shortcuts in general, also for future updates. I'll show you some hydrogen bonds, and maybe you have time for some 3D stuff as well. All right, so let me first talk about FASTA. So FASTA is an coding system for peptides. So you have different letters, and they encode for amino acids, and that is very popular in bioinformatics application. And so you can go to most bioinformatic databases and get FASTA code out here, and then you could use this to visualize it in ChemDraw. So I want to show you some options how you can do that. And now let me jump straight back into ChemDraw. So I have here 2 things. Yeah, let me start with the FASTA one. So I have here a whole protein. I advise that you don't do this with whole proteins because you will bring ChemDraw to its knees. But we can take a smaller sequence of just a subpeptide to visualize this. So one function that is really useful to do this, you find it under Edit, Paste Special, and then you can say FASTA peptide as we have here. And now, yeah, maybe I quickly go to the other window and I paste it in here, and then I will have less trouble. Okay, so we copy in the FASTA peptide, and you now see this is a very popular depiction in the biological field, that you also encode with colors. But that is just one way to do this. And if you want to do this as well in ChemDraw, you can do this by applying the document settings. So that is a formatting standard, and it's called sequence graphic monomers. And then your FASTA sequences or your Helm sequences as well will be depicted as this. Now, let me do this with the normal formatting, and I've noticed that for some reason, if I copy this in or I paste this in, it's going to end up in the middle of the document, and now I have a very long document, so that's a bit of a pain. So we copy it up here. So this is now such a sequence. You see it looks a bit different than what we've done up here. And now the advantage of this is that we can use this to create an actual structure of molecular formula. And with that, I select this thing, then I go to structure and I say expand the label. And now this takes a few seconds. And now we have a nice molecular drawing of this peptide. As I said before, this works reasonably up until a certain size. I mean, you also see now it's getting pretty big. It covers several sizes. I could real scale it, but at some point you will have trouble seeing anything. Okay, then the other thing that I wanted to tell you, it's a similar system. This is called Helm, and we can basically do the same, edit, paste special, and here is Helm. That is a bit more whereas FASTA is very popular and also easily readable, this is a bit more specialized, but also allows you to encode more complicated structures. And so when we have copied it in, then it should now also look similar to what we've seen before with the FASTA sequence. Okay, so that was some of this new functionality. Then what I want to show next is the CIF files. And with that, I go again to a new window. So I have here a crystal structure that I downloaded from the Cambridge structural database, and I can basically just drag and drop that into ChemDraw. So let's see what happens. So now I have a nice 3D structure. I can rotate around and play with it. And so maybe let me quickly also say that there's a new functionality, which is if I press Shift and Alt and move the arrow key, I can do some stepwise rotation. So left, right, but also up and down to have some control over this. And then the next thing that I also want to highlight is that I can also export this. There is a new way to export this 3D data. So that is from the crystal structure. And they have a new file, which is called, they're both called 3MF. And they are, that is a standard for 3D printing. So if you have a molecule that you would like to print, and now here we have this normal formula. Oh, now I forgot the name. So, but it's a more space filling type of 3D representation. So it's more the sausage type where a bond and atoms are sort of connected by tubes. So that kind of representation is what you will get here. So yeah, let's quickly do that. I'll save it on the desktop. Do I have? Let me quickly get that link out here, and then we can see if we can have a look at what the representation looks like. So here, that is just an online visualization tool wherein I can look at such a structure. And now I quickly have to go through the desktop, see where I have my 3MF file. And then it will take a moment to actually look at this. If it takes longer, now it comes, hopefully. So I can zoom in on that. So now here, surprisingly, it looks different now. So before I didn't have a ball and stick model, but you see that I have now a 3D representation that I could potentially print. But so there must be some hidden settings that I haven't figured out, because for before I didn't have the ball and sticks, but more the sausage tube type representation. With that, so that is one new feature. Then I want to highlight the hotkeys. If you ever forget them, you can find them up here in the help. There is one for the hotkeys and the shortcuts. And the hotkey sheet looks like this. And if you go further, there is a shortcut sheet. That one I find more confusing actually than helpful, but because you really have to think about what this might mean, what they want to tell you. But you can find some new information here. So, and before I move to the hydrogen bonds, let me quickly show the two new hotkeys that are now included. So let me first start with a text field. I make an iron atom here. And so one of the new hotkeys is if I use J, then it will quickly draw me a ferrocyanil ligand. And if I do this with Shift and J, then I have a pi-bound aryl ring. This can potentially be useful if you work in inorganic chemistry, work with complexes, ligands. I'm not quite convinced, so it doesn't work in every case. So let me just show you some use cases where it doesn't work so nicely. So now I have, for example, I have drawn one bond sideways, and if I now press J again, it doesn't work. But what I can do is use the atom here as an anchor to add another C peering. So that works, but it's not very intuitive. So these are two new ones of them. And then the last thing I want to show you, so this is also using the Helm representation. So here I choose, I'm working with DNA base pairs. And so I use these structures. First, I just drew this AG. I converted it to the Helm by, as a fast DNA. So I added it in, and then I got this representation. I could expand it, and now I have these two DNA base pairs. And of course, I moved them around a little bit so the base is aligned, because it doesn't look so nice. And I want to highlight this new feature here. Here we have one function that is a hydrogen bond. The other one is just a dashed bond. So let's quickly see what the difference is. So if I do this here, typically if I make a bond from an atom that has a hydrogen attached, then the hydrogen disappears, and here it doesn't. You also see that now I get a warning. So here we could connect it to, and I think the warning arises, let me quickly expand that, because the system still prefers the hydrogen bonds to be mentioned explicitly. So I'll quickly do that. And you see now, if I have distinct hydrogen bonds, then it disappears, but it still has a problem here with the one directly going to the heterocycle. So this is a nice feature. If you want to highlight hydrogen bonds, the warnings, if you export or just copy it over in your presentations, they will disappear. So that is not that much of an option, an issue. And with that, I want to close this. There is also a coffee lecture card that highlights some of the features of ChemDraw, and you can find this under the following link. And if you have any questions, then feel free to unmute. And if there are no questions, then I want to thank you for your attention. And I hope you join again tomorrow to hear about Medicines Complete and how it can help you find information about the pharmaceutical use of chemical substances.